So this is the second part of the video, trig in the coordinate plane. So we talked about standard position, and really don't have time to rehash. Go ahead and look at the first part of this video. We talked about reference triangles, how you always make the right triangle in reference to the x-axis. And we talked about the tie-in of the new reference angle to the original angle and how all of that works. Then we were next talking about the ratios in a Cartesian plane. And so we said, hey, the sine is opposite over hypotenuse, but you know what? The opposite is the value of the y-coordinate. And the hypotenuse is the radius, so the sine is y over r. And we did that for all three trig functions, sine, cosine, and tangent. Also noting that we could find the value of the radius, the hypotenuse, by the way, by doing the Pythagorean theorem. So remember, this is the hypotenuse. All right, so it's just a different way of thinking. So we went through this first example. We had a terminal point of -3, 4. Therefore, then we were able to do the sine by y over r. Y is 4, and r is 5. We used the Pythagorean theorem to figure out that y was 5, although it was a 3, 4, 5 triangle. All right, now look at the cosine. Cosine of z. Now remember, the cosine is x over r. And notice by doing this, the fact of the positive negative is cared for by the math. So if you go ahead and write in the top, what is the value of x? It's a -3. See, the opposite is a -3. And what is the hypotenuse? 5. I'm sorry, the adjacent is a -3. What is the hypotenuse? 5. And so the cosine of z is -3/5. And then we can do the same thing with the tangent. Remember, the tangent is the opposite, which is y, over the adjacent, which is x. And so we're just going to do the coordinates. What is the y-coordinate? It is a 4. What is the x-coordinate? A -3. And remember, don't leave your negatives in the bottom. Put them in the top, -4/3. So we can know the coordinates of the terminal point. That's the end point. And again, because that ends up with a reference triangle, we really don't even need to worry about that. We can simply figure out the radius, use x, y, and r, and get all of our trig functions. X, y, and r, and get all of our trig functions. All right, let's look at the next example. So in this next example, we say find sine of alpha, cosine of alpha, tangent of alpha in the coordinate plane. And that should be if the terminal point, if the coordinates of, okay, we're good, if the coordinates of the terminal point are -4, 8. All right, so first thing you got to think about is where would that terminal point be along our circle? So we're marking out an arc, and where is -4, -8? Well, hopefully you think of the x-coordinate of -4, and here I'm just going to go 1, 2, 3, 4. So there would be your x-coordinate, right? And on the y, we got to go, what, 8? 1, 2, 3, 4, 5, 6, 7, 8. Not quite the scale, but it worked. Okay, and actually 8 should be up here, and that's probably better. And if you intersect them, then we're probably going to be right about here, right? And that's fine. So there's our point. Here is our side, which again is the radius. And notice now alpha is right here. So let me write the coordinates here. The x is a -4, right? And the y is a -8. Okay. So remember, we know x, we know y. If we're going to complete all the trig ratios, we do need to find r. So let's figure out the radius. So you got a -4 squared, which is the same as a +4 squared. That's a 16. Plus a -8 squared, which is the same as a +8 squared, which is a 64, because negative times a negative is a positive, right? So what is our radius? The square root of 64, 74, square root of 80. And of course, we would always simplify, right? You're going to simplify square root of 80. All right, what is an 80? That is a 4 times a 20. That's the way I would do it in my mind. And so we're going to get a 2 out for the 4. And what is a 20? A 4 times a 5. I'm getting another 2 out. And so we end up with the radius of, and I should finish this, 4 times the square root of 5. Okay, it's an exact answer, and we'd rather use that. So again, when I do the sine, I'm going to think sine is y over r. Okay, here you go. What's the value of y? It is -8. What is the value of r? It is 4 times the square root of 5. Now, am I going to leave my answer like that? No, because we're looking for exact. We're going to rationalize the denominator. So before I do that, I can divide the -8 and the 4. And now I'll rationalize my denominator, square root of 5, whatever I do the bottom, same thing the top. And where do we end up with? -2 times the square root of 5 over 5. And that's the sine of alpha. Okay? I'm going to do this for the cosine and the tangent. So again, what's my cosine going to be? X over r. What is x? -4. What is r? 4 times the square root of 5, right? X over r. Now again, if you can't do that in your head, write it down. Going a little fast here for time's sake, because I got to get this in before my next class. And again, you can reduce and rationalize, right? And most of you see already where we're going to end up here. We're going to end up negative the square root of 5 over 5, right? Negative the square root of 5 over 5. Why are both negative? Remember, the sine and the cosine are both negative in quad 3 because the opposite's negative in quad 3 and the adjacent's negative in quad 3. Okay, so that is the cosine. Let's go ahead and do the tangent. Remember, the tangent is the y, the -8, divided by the x, the -4, which again is exactly the same as the opposite over the adjacent. All right, reduce that. Notice tangent is positive in quad 3 because you got a negative divided by negative, and it is a 2. Okay? Now that's key. You need to work on trying to understand what's going on here, because next lesson we're going to apply this to what is called a unit circle, and then things begin to get tied together to the trig function, so in a little bit different way. So again, all we're doing is using the fact that the x is the same as the opposite, and the y is the same as the opposite, the x is the same as the adjacent, and the r is the same as the hypotenuse, and therefore we're writing these relationships. So again, this is what you're focusing on, right here. So the first set is the old way, right? This was the first way we learned how to think of a sine, cosine, and tangent. And the purple box is now the new way that we're going to think of the sine, cosine, and tangent. The first way is just dealing with triangles, and the second way is really when you're talking about in a Cartesian or a coordinate plane. Okay, so then let's get to a few more examples. So then they could ask you something like this. What are, find the sine, cosine, and tangent if the terminal point is 0, -7. Okay, so I already drew that for you. 0, -7. Remember, the 0 is the x, the -7 is the y. We do need a radius, right? So 0 squared is 0, and -7 squared is 49, and guess what? The square root of 49 is 7. So the radius is 7 on this. And look, rightly so. How long is that segment? 7. So again, we're ready to do the sine. Remember, the sine is what over what? Y over r, because y is the opposite. Y is the opposite. That's a -7 over r, which is a 7. And what is the sine? It is a -1. By the way, we just found that the sine of 270 degrees is -1. And you can punch that in your calculator, and surely it'll tell you the exact same thing. Because it doesn't a terminal point of 0, -7 give you a 270-degree angle? It does. All right, cosine. Now we're going to do the adjacent, the x, which is a 0, divided by the radius, the hypotenuse, and in this case, we get 0. So what's the cosine of 270 degrees? 0. Now in the third instance, remember we're going to do the y, the -7, divided by the x, which is a 0, and what does that become? What's the answer to this thing? How about like negative infinity? Negative infinity. Later on, when I show you the graph of the trig functions, I'll show you how this is the case. You know what? Let me just real quick. Real quick. If I were to do the tangent, this was a -90, +90. So that's 180, 270. Here's what the tangent looks like. It goes like this. It's in intervals. Of course, it's periodic. So, and again, the next one would start here and go through. So what is the tangent of 270? It's infinity, and in our math we can say negative infinity for 270 because of a -7 divided by 0. Okay? Some just say infinity, some say negative infinity. All right. So, then that leads us to a couple other things. G, give the exact value of cosine 210. All right, so now this is going to get back into the aspect of the pattern thing, remembering that how our pattern sets things up and what goes on with the different angles. All right, so I want the exact value of the cosine of 210. So let me draw the terminal angle. So 210 is about right there. Terminal angle, the angle with the terminal side. So this is 210 degrees. What is my reference angle? 30 degrees, right? Reference triangle, right there. So now in this, in a question like this, because they didn't give us the coordinates of the terminal point, I'm going to go back to thinking adjacent over hypotenuse. Okay, so now I got to think about what I just created was a 30, 60, 90 triangle. And I need to take my pattern and properly label everything. So you got to make sure that you, in your mind, flip the triangle the correct way to get things in the right spot. The easiest is the hypotenuse, right? In this case, it's a 2 off of our pattern. Okay, not a problem, right? That's clearly the hypotenuse. Okay, and then the way I look at things is, you know, from the 90 to the 60, which would be here to here, is the 1. And is that 1 positive or negative? It's negative. And from the 30 to the 90 is the square root of 3, and from the 30 to 90 is here, and so this is square root of 3, and it's a negative. Okay, now I'm ready to go ahead and do the cosine. So what's the value of the adjacent? Negative the square root of 3. What's the value of the hypotenuse? 2. And what's the exact value of the cosine of 210 degrees? Negative the square root of 3 over 2. Negative the square root of 3 over 2. So that's the idea, and actually I was going to write it down here, and that's why I reproduced it there, but that's the idea. You're going to use your pattern. Again, in this instance, I would go back to thinking cosine is adjacent over hypotenuse. Why? Because they didn't tell me the coordinates of the terminal point. They did, I just do it that way. They could have, they didn't. So I used the pattern that we learned and applied it to this 30. Without the pattern, we wouldn't be able to do this. Okay? But we did it with the pattern of the 30, 60, 90 triangle. All right, I'm going to add one more thing to your notes here, so I think it'll help you. So we're going to do one more And this is going to, I'm just going to call it h. And let's do the exact value. So I'm just going to write exact. And I want the cotangent x for a negative 420 degree angle. Cotangent x for a negative 420 degree angle. Okay, if I were doing this problem, what would I do? I would first make a Cartesian plane and I would draw this angle. All right, here's my initial ray. And now I have to open negative 420. All right, so watch on the right. Just watch this and then draw it afterwards. You can always pause the video. There's negative 90, negative 180, negative 270, negative 360, and I have to go another negative 60 more for a grand total of negative 420. And I end up right there. Okay. Now, remember, your reference triangle always goes back to the x-axis. So how much is our reference angle? 60 degrees right there. If you wanted to, you could put the 30 there. Now we're back to the pattern. Let me move this up so you can see the pattern. So now let's write out. What's our hypotenuse again for a 30, 60, 90 triangle? It's a 2. All right, from the 60 to the 90 is the 1. Therefore, the negative 1 is right. I'm sorry, it's a positive 1, right? We're on the positive x-axis. So that's a positive 1. And from the 30 to the 90 is the square root of 3, only this time we're negative and negative square root of 3. So now what do I do to do cotangent of x? I say this, the cotangent of x is the adjacent over the opposite. All right? So the cotangent of negative 420 degrees is going to be the adjacent. Here, I might as well use my color. And remember, we're looking at the 60 degree angle, right? Right here. 1 is the adjacent. And what is the opposite? Negative the square root of 3. I've got to clean that up by rationalizing and putting the negative in the top. Final answer, negative the square root of 3 over 3 is the exact value of the cosine of negative 420 degrees. All right, I hope that helps you. Again, I know you had to watch a video. Sorry about that. You're going to have to spend some time tonight to get things figured out, and I hope you will. All right, that's it.